Is that what's his name?
And then we must have
Psychology. I don't believe to use actions.
your hate.
No, I just don't think that would be
I would say
fair.
actions.
I think it would.
I have one of my drums sitting in my house right now, and I have to take another one home today. My kitchen's gonna be full of production.
You know what?
Like they're not like moving.
I feel
How are you talking about that?
Good morning, ladies and gentlemen. How are we doing today? Wonderful, wonderful, wonderful. Phones and headphones away, ladies and gentlemen. Take out your computers, open them up, and let's get to slide number 37 so that we can finish things up today, ladies and gentlemen. All lefty. Questions before we get going today, ladies and gentlemen?
None today. It's finished. Up to you.
Your final exam, ladies and gentlemen. Thursday, okay? The 29th. You guys are at 7:30 in the morning. You get to start your day with me. What better way is there than that, ladies and gentlemen?
7:30 to what?
7:30 till I say you can leave. Which will be at 9 o'clock when I kick you out, whether you are done with the test or not. So, questions? Good. Today let's talk about the forces within and between atoms, ladies and gentlemen. So bonding forces, basically, ladies and gentlemen. What are the two types of bonds? Covalent and ionic. There's actually a little bit more to it to that, and we're going to talk about that today, ladies and gentlemen. So let's get going. If I was throwing things at you, you would have gotten hit with them. Okay, so they're what are called intramolecular forces. This is one of the two types that are on your yellow sheet, ladies and gentlemen. These are forces within the atoms that hold them together. These are technically known as bonds. So the forces that hold two atoms together, bonds. The strongest force is what is called the covalent network solid, ladies and gentlemen. This is a covalent network solid. What substance is this? Good. What substance is this? This is the hardest substance known to man. This is a diamond, ladies and gentlemen. Covalent network solid is all of these bonds in here making one very, very, very strong substance, diamond. Covalent network solids are the strongest type of bonds there are on the planet, ladies and gentlemen. But the only element that does this, carbon, maybe silicon. This is a diamond, ladies and gentlemen. This is just carbon atoms combined. This is graphite, ladies and gentlemen. This is just carbon atoms combined. So who knows? Someday you may be a writing utensil like graphite, ladies and gentlemen. Me, I'm going to be a diamond someday if I choose to die. Questions? I'm not going to.
So that little piece right there is that.
So that little piece right there. Correct. That little piece on the end of your pencil is this. And by the way, when you write, it breaks bonds and leaves a part behind on your paper. Which bonds break? These long ones. Because they're not as strong as these small ones here. Okay? Covalent network solids. Okay? They are bonds within carbon and silicon atoms. Second strongest bond is an ionic bond, which means it's between a what and a what? Between a metal and a non-metal. Okay? An ionic bond is the second strongest bond. Covalent network solids are the strongest. Ionic bonds are second, ladies and gentlemen. Okay? Now, the relative strength of an... you want to go and do that and then I'll teach later? Or?
Oh, no, you go right now.
Because there will be time at the end for you to get him caught up on what he missed. Okay, thank you. The relative strength of an ionic bond in general is based on the formula mass. So if you have two ionic bonds and you're trying to figure out which one is stronger, ladies and gentlemen, we're going to look at the formula mass. The larger the formula mass, the stronger the bond in general. That's what we are going to go with. Question. Okay. The third type of bond that we have never talked about, ladies and gentlemen, is metallic bonding. Metallic bonding is the bonding within metal atoms. This is how we get things like sheets of tin, sheets of aluminum, sheets of gold. Okay? There has to be some force that holds those gold atoms, those tin atoms, the iron atoms together. That is called metallic bonding. Okay? Now, metallic bonding creates what is called a sea of electrons because metals want to lose electrons. When metals are connected with each other, and we're not talking about different metals bonding together. We are talking about the forces that hold iron together. We are talking about the forces that hold copper together, that hold silver or gold together. You get what is called a sea of electrons, which is electrons will literally move around the metal. Why? Because each metal atom is trying to lose electrons. So it kind of passes them off to the next atom, and then that atom passes them off, and then they keep moving. This is the reason, ladies and gentlemen, that metals are very good at conducting electricity, because the electricity is the movement of electrons from one place to another. Again, the relative strength of a metal bond is dependent on the formula mass. So we're going to use that as kind of a theme. So if you have two metals, gold and silver, which one has a stronger bond, gold or silver? Why? You answered so quickly, I thought you had it.
More of a metal, stronger metal.
Silver, right there. Formula mass, 107.8. Gold, right underneath it. Formula mass, 195.8. Which one has a bigger formula mass? So it's got a stronger bond. Question. By our rules, it would have a stronger bond. Questions? Yes?
Isn't gold more malleable than silver?
Yes. Which is probably why. Probably why you can pound it into a thinner sheet, because the forces holding the atoms together is much stronger. When you try to do that with aluminum, it just doesn't work. More mass, stronger bond. Questions, ladies and gentlemen? Now, I don't think ionic is on your yellow sheet, is it? Good. Moving along. Now we get into intermolecular bonds. This is one that is on your sheet as well. Intra and inter. These are forces between molecules. Molecules are covalent bonds. This is the weakest type of bond as well. So of the Types of bonding: covalent network solid, ionic, metallic, and covalent. Covalent is by far the weakest, ladies and gentlemen. By far the weakest. Okay? But there are different types of covalent bonds. By the way, again, the relative strength of covalent bonds is dependent on the formula masses. So the larger the formula mass of the covalent compound, the stronger the covalent bond that is. It's still not as strong as ionic. It is still not as strong as metallic. It is definitely not as strong as covalent network solid. But for a covalent bond, the ones that have the higher masses are stronger. Now, there are three types of covalent bonds we will talk about, ladies and gentlemen. The first is what is called hydrogen bonding. Now, again, we have said that hydrogen is a unique element on the periodic table. Why?
One valence electron.
Yes, and we said it can act as a and a good. Now, might be important to know that on your test. Only element on the periodic table that acts like a metal and a non-metal is hydrogen. Hydrogen. Okay? Now, technically, though, hydrogen is a what? Non-metal. Non-metal. So, even though hydrogen can act like a metal at times, there are some who say, well, because hydrogen's a non-metal, you cannot make an ionic bond out of it, even though it may sometimes act like it. So hydrogen bonding, ladies and gentlemen, is a strong intermolecular force between hydrogen and four other elements: nitrogen, oxygen, fluorine, and chlorine. Nitrogen, oxygen, fluorine, and chlorine. Four of the most reactive what? Non-metals. Okay? But you can only have hydrogen bonding when you are with these four. Not with anything else. By the way, which one is going to be the strongest? What? Hydrogen bonded to fluorine? What?
Chlorine.
Why chlorine?
The biggest mass.
Greatest mass. Greatest mass. Okay? Greatest mass would be hydrogen bonded to chlorine. Then hydrogen bonded to fluorine. Then hydrogen bonded to oxygen. Then hydrogen bonded to nitrogen. Even though there would be more hydrogens, with hydrogen bonded to nitrogen, hydrogen only has a mass of 1. Okay? Van der Waals is on your yellow sheet, ladies and gentlemen. Van der Waals forces are a medium intermolecular force between polar covalent compounds. Eh? First of all, covalent compound, what's happening between the electrons? Polar compound, what's happening between the electrons? Polar compound, what's happening between the electrons?
They combine. I combine.
Glad we went through that whole table yesterday about SP, SP2, SP3 hybridization, all those geometries. And we talked about in those compounds, what is happening between the electrons? They are being what?
Shared.
They are being shared. Thank you very much. They are being shared. Okay? Now, what are the two ways you can share things, ladies and gentlemen? Nope, that's not sharing. Sharing means you both have them and you're splitting them. What are the two ways you can split things?
They're close. Nitrogen.
What are the two ways that you can split things?
Sharing.
Good, keep saying the words and that isn't going to help.
Bonding. If you have one electron, you know, needs it.
You'll share it with them.
Yeah.
Good, what are the two ways you can share it with them? No, you cannot share by gaining and losing. Stop saying that. If you win a big prize, what are the ways you could share with somebody? What? Combine.
Best word?
Combine. Didn't we talk about the Monopoly game yesterday?
Yeah.
What are the 2 ways you could share?
Compromise. Split it.
80,
How?
80, 20,
Yeah.
Or,
70, 30,
or,
90, 10.
50,
90, 10.
well, what's 50-50?
half.
Sharing what?
Something.
Evenly.
Yeah.
What's 70-30? 80-20, 90-10?
Uneven.
Okay. So, a van der Waals force is when 2 atoms are sharing electrons, but they're not sharing them evenly. They are not sharing them evenly. That means the electrons will spend more time around one atom than the other. Okay? It's like when my wife and I go to the movies and we get popcorn. He who eats the most gets the most. Okay? There's no even sharing. That's out the window. You want some, stick a hand in there and grab what you want. And he who eats the most gets the most. So, imagine 2 atoms sharing electrons. Okay? 2 atoms sharing electrons. Well, let's put hydrogen, and it's 1 electron, and I can't put it with those 4, right? Because then it would be what? Would be hydrogen bonding. Okay? So let's put it with bromine. Okay? Bromine has how many valence electrons? 7. Thank you. 7. No problem. So what are these 2 electrons going to be? Between the 2 atoms? Shared. That's what we mean by being shared, correct? Now, bromine is way over on the left or right hand side of the periodic table, correct? What did we say happens to electronegativity? What did we say happens to electron affinity as you move from the right to the left? They do what? Instead of guessing, why don't we look at our periodic table and say it? As you move across, not up and down, across, they increase. So, which one of those, hydrogen or bromine, is further to the right? Bromine. So what that means is even though they're sharing these electrons, ladies and gentlemen, this electron right here is going to spend more time around this one than it is around this one. So if it's spending more time around this, that's like bromine having an extra electron, correct? Which means, what does that mean for its charge if it were to just go to bromine? If it were to just go to bromine, what would happen to bromine's charge? But what charge would it have? If bromine gained an electron, what charge would it have? Guys, come on. It's written on the periodic table. What charge would bromine have if it were to gain an electron and become stable?
0.
No.
-1.
-1. -1. How many protons does bromine have? How many?
35.
35. So how many electrons does it normally have? 35. If one more is spending a lot of time around bromine and it has 36, what charge would it have? -1. Now, here's the thing. This is not a formal charge. It is like it gets a charge, but because the electron didn't actually go to bromine, it's just spending more time there, it's not an official charge. But it would be kind of like being a -1, which would mean what would happen to the hydrogen?
It becomes stable.
It would, but that electron is spending more time over here than here. So if this becomes kind of negative, this becomes kind of positive. Not officially. It's not transferring. But because this electron is spending more time here and here, and because it's like it's a charge, this is a fairly strong bond. This is a fairly strong covalent bond. Why? Because even though it's sharing electrons, it is kind of ionic as well. It is not truly ionic, but it is kind of ionic. Questions? Okay, that's van der Waals. And again, okay, polar covalent compounds, if you have lone pairs around the central atom, or if the molecule lacks symmetry, okay, or if the molecule lacks symmetry. Here's a lone pair around the central atom. Would this be van der Waals? Yeah. That's what would make this van der Waals. Would this be van der Waals? Why not?
Because it doesn't lack symmetry.
This has perfect symmetry. These three are as far away from each other as they can get, correct? And there's no lone pairs here. So therefore, this cannot be van der Waals. Van der Waals or not? This can't be van der Waals. Why? There's no lone pair, and there is... No, this has symmetry, right? Same shape everywhere. That's what they mean by symmetry. Same everywhere, right? Okay? All right, so now... Chlorine is a diatomic, correct? What do you notice? They're sharing. Okay? They are sharing. Okay? Which of these chlorines would attract the electrons more?
Wouldn't it be the same? So the same mass?
Should be. They're the same. Well, not only the same mass, they're the same exact element.
Yeah.
So they have the same exact reactivity, right? Okay? So these electrons, these ones in the middle, would this become a polar compound if they're shared evenly?
No.
No. This is not a polar compound. They are shared evenly here. Okay? They are shared evenly here. This is called London dispersion forces. This is also on your list. This is the weakest intermolecular force. The weakest. And it is between two nonpolar covalent compounds. Ooh. Sorry, I said this were van der Waals. That's not right. The molecule has to lack symmetry for van der Waals. This does not lack symmetry. Sorry, my bad. My bad. This would be London dispersion. Why? The charges are evenly distributed here. Okay? Evenly distributed because of the symmetry here. By the way, London dispersion. Every single diatomic has London dispersion. Why? No one of these elements is going to hold on to the electrons more than the other. Here, London dispersion. Here, no, not London dispersion. Why?
Because it's not equal symmetry.
And there's 3 lone pairs over here. That's going to cause the electrons to not be shared evenly. Okay? The electrons here are not shared evenly. By the way, anybody remember what this compound was? Nope, the compound. Take a drink and think about it. Take a drink and think about it. Which is? Water. Water is a polar compound, ladies and gentlemen. You know what that means? Ice. What does that mean? Fur. Here is a dead bunny. Here's a plastic rod. We're going to rub the dead bunny on the plastic rod. What does that do to the plastic rod? What? Builds up a static electric charge. Which when we bring near water, ladies and gentlemen, causes water to do that. Why? Water is a polar compound. Water has a positive and a negative side to it. And when you bring a charged object near it, it will be attracted to that opposite charge. That's a polar compound. Diatomics won't do this. Why? They're nonpolar. They're nonpolar. Okay? Only polar compounds will do that. Okay? Questions?
Where'd you get a dead bunny?
From the dead bunny store? It's okay. I got a piece of genuine imitation silk from one of Mr. Arts' old shirts. And now that he's gone, I can bring it out whenever I want. I don't have to hide it anymore. Let's not say stolen. Let's say acquired.
Taken.
Questions? Okay. Properties like boiling point and melting point depend on forces of attraction to hold atoms or molecules together. Sure. Can that pipe on the wall melt?
At the right temperature, probably.
Yeah, right temperature. Probably about 1800 degrees. But this room doesn't get up to 1800 degrees. Boy, I'd hate to hear you guys complain about how hot it would be in here for once.
It's so cold.
You're right, it is. That's why I'm wearing a short sleeve shirt. So, we can get this to melt. But we would have to add a lot of energy. Can we get the water in here, in that container, is already what? Which means what? It is already what? It is already melted. Why? Okay, and it has a much lower melting point than that pipe on the wall. The room temperature is hot enough to have already melted the water. Why? The forces that are holding the water together aren't as strong as the forces that are holding the pipe together. What kind of bonding in that pipe? Don't bother to look at it and see what it's made out of.
Metal.
So what kind of bonding? Metallic, which was stronger than water, which is polar covalent, which makes it van der Waals. Metallic, stronger, van der Waals. Harder to melt, easier to melt. Now, what kind of forces would hold the oxygen in the room together? The O2 molecule.
That would be London, yeah.
London dispersion. What else is in the air we are breathing? What's the formula for nitrogen? N2, diatomic. What kind of forces? London dispersion. And those things have not only melted, They have what?
Turned into a gas.
Which means they have
Evaporated.
boiled. Boiled. Why? They have a very low boiling point. For oxygen, it's like minus 183 degrees Celsius.
Oxygen magnetic.
What?
Is an oxygen magnetic?
It can exhibit magnetic properties, yes. Okay? So the point being, ladies and gentlemen, depending on what type of force, that's going to help determine things like boiling point and melting point. How strongly something is held together. Now the desk, the wood in this desk, is held together strongly enough that you can't melt it. What will it do? It'll burn. It'll break down. It won't melt. It'll burn. Question, Josh?
Your answer.
Okay. So we're going to place these elements in order of their melting or boiling point. It's going to be determined by the type of force holding each substance together. We're going to place in order from the strongest to the weakest force. If two substances have the same force holding them together, we're going to determine it by mass. So place the following in order. All right. So, ladies and gentlemen, we have just talked about these different types of forces. H2S. What type of force is holding that together? Covalent network solid, yes or no?
Yes.
No! There's only one thing up here that's a covalent network solid. What is it? Look at the list. What's the covalent network solid? Good. Now look at the list and tell me which one it is.
Is it carbon?
Yes. Yes, it's carbon. This is the covalent network solid, ladies and gentlemen. Good, 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 good. My gosh, you're starting to worry me, ladies and gentlemen. I was beginning to think I wasn't a very good teacher. Covalent network solid. All right, let's do this. What is the second weakest type of bond? On that first page, what was the second weakest? Covalent network solid was the strongest. What was right underneath it? Okay, which of these are ionic? Look at the compounds. Which ones are ionic? Second one, lithium fluoride, ionic. NaCl, ionic. Nope. What? NF? Nope. That's not a metal and a non-metal. Ionic is only between a metal and a non-metal.
H2S.
What?
H2S.
Nope. NF. NF. Nope. Not a metal and a non-metal. All right. Where are the metallic ones? Any others? Okay, so now we get to covalent. And we said there were three types of covalent. What were they? Okay, so which one of these is hydrogen bonding? Is it?
No.
Then why'd you tell me the first one?
Because I tricked myself. HCl.
HCl is the only one that is hydrogen bonding. Okay? So then, what does that make this one? Why?
Because the other ones are diatomic.
Okay, so the diatomics would be what?
London.
London dispersion forces. So then that makes these van der Waal, correct? Okay, so which one is the strongest? So we're putting them in order of strongest to weakest. Which one is number one? The carbon. What's the second strongest?
The silver.
Nope, not the silver.
Ion.
Ionic, but I got two that are ionic. I got this one and I got this one. How do I determine which one is stronger? Okay, which one's heavier?
Do we take the combined one?
Yes, formula mass. Oh my gosh, which one's heavier? Thank you. Chlorine is 35.45. Sodium is 22. That's 58 point something. Lithium, 6.9. Fluorine, 19. 6.9 and 7, or 7 and 19 is 26. That's not even up to the chlorine here. Again, I'm just doing a quick math approximation, right? So then this is 3. What next? Silver, the metallic bonding. Very good. What next? Hydrogen bonding. That is this one. I don't know whose phone keeps making noise, but shut the damn thing off before I take it away. Then what? Okay, which one? Here or here? Fluorine, 19 times 3. That's almost 60 plus 14. This is 32 and 2. So yes, this one is next. 6, 7. All right. Which one of these is next? Bromine. There you go, ladies and gentlemen. Questions? Okay. Now, there are more slides in here, ladies and gentlemen, but we will not be getting to them. We will not need to go into energy and chemical reactions and things like that. Okay? But real quick, in order for there to be a chemical reaction, ladies and gentlemen, 3 things have to happen. 3 things have to happen. When 2 atoms hit each other, that's the only way they can combine, is to actually have a collision, to actually run into each other. Then when they hit each other, they have to have enough energy that they will transfer electrons or share electrons. If you don't have sufficient energy, you cannot have a chemical reaction. You have to have collisions, and then when you have the collisions, things have to be lined up the right way so that we can get hybridization between S's and P's if it's a covalent compound. Or they have to be able to transfer that electron that's in the outer shell if it's a ionic compound. The chances of these 3 things happening are not great, yet chemical reactions happen all the time. Why? Not necessarily the amount of chemical reactions that happen, but even if we have a small amount of carbon, a few micrograms of carbon, how many atoms do we have? A lot. A lot. So simply because there are so many atoms in a mole, reactions happen. Reactions happen. Okay? We're not going to worry about reaction rates. We're not going to worry about factors or any of those things. What we are going to worry about is take out your packet right now, close your computers, and get to worksheet number 7. Okay, ladies and gentlemen, I cannot display the questions and the answers at the same time. So you're going to have to help me here. Okay? I cannot do both at the same time. So here we go, ladies and gentlemen. Worksheet 7 is the one that has this at the bottom of it. Now, on your, didn't take. On your test, ladies and gentlemen, I will have the periods and groups numbered for you. On this one, I do not. Oops. So this is the answers that we're looking for, or this is the part that we're doing. Now, my suggestion is when you take the test, Each answer can only be used once. So I would cross them off as I am using them. But it also might be a good idea that when you read a clue, if Lavoisier is the answer, you think it is the answer, you may want to put LA by it because you may need to come back and find that later. And if you can't find that clue, you're going to have problems. Now, if you are 150,000% sure you're putting it in the right spot, you shouldn't need to come back to it. But if you are guessing on a spot for an answer or guessing as to who the scientist is, you may want to put the answer on the side column by the question so that you'll have an easier time finding it if you need to come back to it. Your choice. Okay? Read me question number 1, Eric.
The most metallic element is X.
Where's the most metallic element, ladies and gentlemen? Francium. Now, this table is not as big as our normal one. So, where would it be on this table? Because this table only goes 1, 2, 3, 4 to 5 periods. 1, 2, 13, 14, 15, 16, 17. It still has the 18 groups. But again, francium spot is technically not on here. But lower left-hand corner is where the most metallic element always goes. Good. All right. Read me number 2, Morgan. Most non-metallic element is I. What is the most non-metallic element? What? You sure? Okay.
Yes.
I goes there. Maddie, read us number 3.
Elements B, L, W, and J are all unreactive gases, with B being the lightest.
Okay, so where do those go?
Noble gases.
Okay, so underneath the noble gases or above it, I don't care. B, L, W, and J. They are all going to go in this one family. Now, it did give us something about B. What did it say about B, Caden?
It's the lightest.
Where is the lightest member of any family?
The noble gas.
No. The lightest member of any family.
Top.
At the top. So we're going to put B at the top. So I know where that's going. Now, here's the other thing, ladies and gentlemen. I will not give you a clue like this that says, okay, all of these things go here, and then leave you hanging for a long time. So we placed B. Read the next clue, Joshua. Joshua, read the next clue. Joshua, you need to join us and take out your stuff. While he's doing that, Stephen, could you please read me the 3rd clue? I'm sorry, the 4th clue.
W has a larger atomic radius than either J or L.
Okay, so what does that mean for W, ladies and gentlemen? It's got to be below what? Not only B, it's got to be below J and L. Since there are only 3 spots left for these 3, where does it have to go? Has to go on the bottom. So again, I gave you that clue that said they have to be in here. Now I'm giving you a clue that says place this one. Okay? The only way it can have a larger atomic radius than all of the other ones is if it is below them. And J and L would have to go here. Okay? So read the next clue, Angel.
L's in period 2.
Okay? So here's period 2. So this is where L goes. And then J would have to go below it. So you remember when I said you can buy a clue? Maybe this is the time you need to buy a clue. I don't know. Maybe you're worried that you're going to put L and J in the wrong spots. Buy the clue. I'll tell you where L goes. You can then figure out where J goes. I'm not saying you have to. I'm saying it's an option for you. Questions? Good. Next. Next question. Go ahead, Christopher. A, where does that go? Spot marked by a spot of hydrogen. A goes there. Okay. Next one, Josie.
I forgot what that symbol.
Sigma.
Sigma is third period element that is highly reactive with water.
What third period element is highly reactive with water? What? Nope. Sodium. Magnesium is only slightly reactive with water. Sodium is strongly, or in this case, highly reactive with water. Okay, next question. Phoebe.
HKM0Y and 0.
Whoa, stop. I know that's a 0, but it's supposed to be an O, just so you know. Sorry, it's a typo on there. That is a 0. It's supposed to be an O. So go ahead.
Are also third period elements.
Okay, so now, ladies and gentlemen, what were they again, Phoebe?
HKMOYZ.
So again, we know they're going to go somewhere in here, in between sigma and J. Okay? So I put them over here for now, so that I know they've got to go somewhere in here. Okay? Read the next clue, Jaden, please.
H has a larger atomic radius than M and differ in atomic number by 1.
Okay, so what does that mean for those two? If they differ in atomic number by 1, what does that mean? They got to be right next to each other. They got to be right next to each other, correct? H has a larger atomic radius than M. Where does H go?
More left.
H is more left because atomic radius does what as we go across? Decreases. So H has to go first. The problem is what? We still don't know where they really go. All right, so what's the next clue?
Very good oxidizing agent.
Okay, what did it mean? Which one are very good oxidizing agents? Metals or non-metals? Non-metals? So where would K go? K would go underneath I. Well, you could, but it's just underneath it.
Oh, we know that one.
Okay? All right. Jasmine, or Josh, did you read yours? I'm sorry. Go ahead, Josh.
Why is metallic but often it's considered a metal?
Okay, where are metalloids, ladies and gentlemen? Metalloids are touching the staircase. So, you either have to be on one side of the staircase or the other to be a metalloid. Where are the metals that are metalloids? On which side of the staircase? So where does this clue go? 13 what? Period 13. There you go. There's Y. Okay? There's Y. All right, what does it say about O? I'm sorry, the other Joshua, go ahead. Did you read yours, Joshua, or no?
Yeah.
Okay, sorry. Jasmine, can you please read number 12 for us? I think that's where we are. All right, where do you got 6 valency electrons? Group 16, the oxygen family. Now remember, this has to be in the third period still. Why? Because we were told they were all in the third period. Good. Good. All right. Sigma. Okay. So now, ladies and gentlemen.
You can find H and
Okay. So where do H and M have to go?
H is 14.
H is 14.
M is 15.
M is 15. Why, Shenza?
Because that's the only two spots that can next to each other.
Very good. Which means what then?
Which means number 2 is the last one.
Z, the only one that's left. Very good, ladies and gentlemen. Very good.
How do we know that H and M flip-flop? Like what?
Because it said H has a larger atomic
Oh,
radius.
Okay.
Atomic radius does what as you go across? There you go. Decreases. Good questions. All right. Yes, sir.
Can you explain that oxidizing?
Okay. Oxidizing agents. We went back in our periodic trends. So let me find it here. Okay. We said that nonmetals were good oxidizing agents. That was one of their properties. Metals are good reducing agents. Okay. Trying to find it. And then we said the best oxidizing agent, the best was fluorine. The worst was francium. So that was where that was. Okay. Now there was a typo here. Here it says the best oxidizing agent is francium. Well, up here I said it was the worst. This was supposed to be reducing agent. Sorry about that. Okay. Sorry about that. Questions? Okay, good. So let's keep going, ladies and gentlemen. All right. Anybody remember where we were? 13. Ariana.
G has 7 protons.
What element has 7 protons? Count. 1, 2, 3, 4, 5, 6, 7. The spot of nitrogen. That is the easiest clue you're going to get, ladies and gentlemen. 7 protons. There's only one element on the periodic table with that. All right, Michaela, what do you got next? 14.
C has an atomic weight of 5 and forms the proton of Cl.
Okay. So 2 things here. Number 1, I. Look at I. You see it?
Yeah.
What's its charge in a compound?
Minus 1.
-1. So what charge would that have to make C? +1. Where are the +1s? Okay. In this first group, correct? And to have an atomic mass of 5, that means it's got to be near where? Near the top. That's why it has to go there. Why? It can't be an atomic mass of 5 way down here. It's too heavy. Too heavy. Okay? All right, go with the next one. Faith.
Q is a 4th period element with the ionic charge of 4.
Where's it go?
The alkali metals.
In the alkali metals. Only one spot left in the alkali metals. Jeez, that is just terrible. Q. Good. Excellent. All right, next. Jack.
EYR, is that omega?
Yes.
Arranged in order of increasing mass are the same thing.
Okay. So, which one of those do we already have placed? Y. Okay. Now, E, Y, R, and omega. Arranged in order of increasing mass. Down a family, what happens to mass? So what goes on the top? Y, omega. Questions? See, that would be a good question with like 3 colors of visible light. You know, they go down as their energy increases, or they go down as their energy decreases, something like that. Okay, good. Next, Pierce. Really?
Yeah.
Really? What's the triangle? Anyone? It is a triangle, but it's the Greek letter what? Delta. Delta. The heaviest of all atoms, and it is radioactive. Where's it go? Where's the heaviest of all elements on here? The bottom what? That's the heaviest on here, at least. It's the heaviest on here. All right. Number 18. Go ahead. Who's up? Go ahead, Irving. Okay, here's the good news. There's only 1/5 one left. But by the way, are the alkaline earth metals weakly reactive with water? You bet. We showed you that. All right, Achilles. 19.
D is a second period element that forms the salt Di2.
Okay, so Di2. Why?
Because that's a +2.
Yes, if I is a -1 and there are 2 of them in the compound, it must be with a +2. So D has to go there. Good. You guys are doing well. You guys are doing very well. Oh, no, Shenza. Go ahead, Shenza. We're waiting on you.
Okay, fire is used for both brewery and writing. Oh my god.
Utensil.
So utensil industries on Mars and is in the same family as HT and the triangle.
Delta.
Oh, yeah.
It is a triangle, though. All right, so where does F go? What element is used in the jewelry industry and writing utensils? Carbon. Diamond is not used in a writing utensil. Carbon. So F has to go here, and then what else, Morgan? T has to go above delta because it said all of these were in the same family. Very good. All righty, back to you, Christopher.
The most essential Martian liquid is A2N.
What is the most essential Earth liquid?
Water.
H2O. Huh. Look at where A is. A2N. A's in the spot of? So what does that mean that N must be? N must be in the spot of oxygen. All right, JVB.
A acts like a metal in compounds such as AV and like a non-metal in compounds such as Fa4.
Okay, so what's that telling you? But it's acting like a metal in the compound AV. So A we already know is hydrogen, right? So what's it telling us? Well, here's the problem. There's 3 spots left, aren't there? Yeah, but this is not a what? This is not a non-metal. So if it's acting like a metal in AV, what does that tell us? That V must be acting like a non-metal. V's got to be somewhere in there. But it acts like a non-metal in Fa4. Oh, dang it. F is already placed, isn't it? Okay, well, let's go to the next one. Du is a common Martian substance. Which one of those is already placed? What's its charge? So what kind of charge would you have in Du? So where's the -2? There you go. Okay? Now, the last one. Sigma forms compounds such as sigma I2, sigma 3S2, and sigma U. What does that tell you about sigma? All right. Has to be in the alkaline earth metals.
How do you write that?
Make an S and then put a 0 in the middle of it. Make an S, put a 0 in the middle of it. Okay? Okay, but wait a minute. I still have two other ones to place. What other one do I have to place? And S. So it says that it is sigma 3 S2.
So the S must be a 3, or plus 3, or I mean a minus 3.
So that goes where?
To the left of the
Which means V has to go there.
SUV.
Questions, ladies and gentlemen?
SUV. You should make a. Yeah, you should make it spell something.
Yeah, word search out of that.
Okay, we can't on the test. Why?
That would be.
Now, do you want to know the difference between this and your test?
The questions are probably a little different.
No, pretty much the questions are the same.
Oh.
The difference is I'm not going to tell you B is I'm going to tell you the element named after the principal of East High School is a third period noble gas. I'm going to tell you the element named after the highest energy form of radiation is blah, 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 blah. So your question is actually 3 parts at sometimes. Part 1, what element are we talking about? Number 2, what period am I in? And number 3, what group am I in? When you know a period in a group, you have an exact location on the periodic table. Now you only got to figure out what element goes there. Yes?
Did we talk about endothermic and exothermic?
We have in the past. What does endothermic mean?
Yeah.
Endothermic means you're putting energy in. Exothermic means you're taking energy out. Thank you, Josh, because you led me into what we were just going to talk about, which is on that yellow sheet. What are you still missing? Okay, blue, what is it?
A color.
It's part of the visible spectrum. Orange, violet, yellow, all part of that. Some clues may just be bluogen is a third period noble gas. Okay? Or, here's the other thing. You may have to cross them off as you use them, because at the end, it was the last 2, right? Wouldn't surprise me if it's that way on your test. Maddie, did you have a question? Because I kind of cut you off. I'm sorry. Heterogeneous. What does heterogeneous mean? Think back.
Biology.
No. This was when we took and classified matter. Heterogeneous. Hetero? No, but that's what we're talking about, correct? Heterogeneous? Heterogeneous is a mixture that is what? Not the same throughout. Heterogeneous is a ratio that is, or a mixture that is not the same throughout. So what is homogeneous? Has the same ratio throughout. So remember, a salad is a heterogeneous mixture. You can pick out the things you don't like in it. But a soda is a homogeneous mixture. Because you can't pick out the things you don't like in it. Josh. What? Good. Photon. Photon is a bundle of light energy. Dudes, you're not listening to me. You're not writing this down, and you don't know which one he just asked about that I have not defined for you at all. So you may want to write down that photon is a bundle of light energy, and quantum is a bundle of electromagnetic energy. So by the way, because visible light is part of the electromagnetic spectrum, all photons are also quantums. But not all quantums are photons. Only visible light. Good. Next, ladies and gentlemen.
Lambda.
We gave you that. That's the symbol for what?
Wavelength.
Wavelength. What else?
Infrared.
What?
Infrared.
Infrared, part of the electromagnetic spectrum. What else?
Mr. Brand.
The most wonderful chemistry teacher you will ever meet.
Einstein?
Einstein. E equals MC squared.
East High School.
Phoebe, I don't want to come over there and have to beat you, but I will.
Oh.
East High School, what do you think it's going to be?
Fire.
The school you attend.
RDP.
Or it may just, again, some of these may be just East Dion. Is it this?
SDP.
Questions? Is there anything else we're missing on there?
Nothing that we don't know.
Good.
Wait, what's Miss Courage? Oh, that's right. Oh. I thought she had a definition.
Quantum. And it was quantum electromagnetic.
Oh,
Oh, y'all guys are hitting each other. What is that? It's a flat pencil.
Mr. Brand. What's Mr. Brand? The best teacher. The best chemistry teacher. I don't think what happened if I had Mr. Parts.
Practice. It's the only way you get better. Why do you have a carpenter's pencil?
It is.
I got work at
And you're a carpenter?
At McDonald's?
I got 2 jobs.
Dude, you barely do work for one person in this class.
I gotta be up, man.
Okay. Go to work, ladies and gentlemen.
So this is let's start final.
No, that is practice.
Oh, is this periodic? Oh, it's practice. I didn't read that.
I could tell that you didn't read it.
Whoopsie daisy. Oh, boy. Word way.
Manny, I will give you the one, the number 2 one as well. Okay.
Oh.
So that when you get back, maybe you start looking it over before you're ready to come out and take this. Whenever you are available. Okay. You're all day long. Whenever you're available.
I'm kind of scared of
If you want to
doing
come after school and do it, you can. But I would recommend get down there. Okay? The next big one. Okay?
We're gonna do all this like smart. It's AFK, not AFK, like absent. You're absent, like in the game, like you're AFK. Yeah. AFK, PU, ZZ.
Josie, come here.
What?
Where are you going?
To Lilybeth.
To what?
To Lilybeth. Her foot is broken, and I have to help her bring her stuff everywhere.
Well, how come nobody told me this?
Didn't you get an email? They said that they would send all my teachers an email.
I don't remember getting it. I don't remember. Okay, at least now I know, because here I've been just marking you absent every time you leave.
Really? Have you? No way. Really, I haven't realized that.
Go ahead.
I'm sorry. Have a good weekend. I should have like.
You too.
But no, this the nurse Terry.
Yep.
She was just like, oh yeah, no, don't worry about it. I'll email all your teachers.
And maybe she didn't. Maybe I
And she's
maybe
like,
I
I'll
missed
do it
that.
for this try and next try.
What?
I was like,
How long are you going to be helping this kid?
exactly. Till.